Let's have a look at question 1 in this video. So what we have is we have data on the number of hours worked per week and the highest education level. And we have ANOVA results where we compare the number of hours worked depending on education levels. So we have 3 levels of education and we want to see if the average number of hours worked is the same or not between them. And the intuition is that if we have a lower education level, then probably we're not as able to provide as much value or to have full-time jobs, so we're more likely to work less, whereas if we have a degree, we're more likely to work more. At least that's our assumption, but we want to test it. So what are we actually testing here? We're actually testing the average number of hours. The average number of hours for different groups. The first group is high school, the second group is people with a bachelor degrees, and the third group is people with a graduate degree. And the alternative hypothesis is that not all of them are equal. So not all these means, not all these average number of hours are equal. How do we do that? We do it with an ANOVA test. And what is an ANOVA test? Recall that an ANOVA test is a test on variance where we compare the average variance between the groups relative to the average variance within the group. So what are we going to do? We're going to actually calculate it. And we have a table here with data already. We just have to fill it in. So let's start with the beginning. Over here, what's missing is the degrees of freedom. So what are the degrees of freedom for variation between groups? Well, we have to divide the variation between groups by the number of groups minus 1. That's going to be our degrees of freedom. We have 3 groups, 1, 2, 3, minus 1, that's going to give us 2 degrees of freedom over here. Now we do the same for within the groups. To find out the degrees of freedom here, we will have n minus I. So the number of observation minus the number of groups. We have 942 observations in total, minus 3 groups, that's 939 degrees of freedom. So what do we do with them? We calculate the average variation, the mean sum of squares. So the mean sum of squares is going to be 2062.49 divided by 2. That's going to give us 1031.25 approximately. I'm rounding up a bit. Now if we do the same over here, we would have 217,744.5 divided by 939. We would get approximately 231.88. 231.88. Now recall that the F statistic is the division of these two, so we have to divide these two values. 1031.25 divided by 231.88. So let's do it over here. The F statistic would be 1031.25 divided by 231.88, and that would give us a value of 4.45. 4.45. So that's quite a high F value. What does this F value imply? It implies that the variation, the average variation between the groups is 4.45 times higher than the average variation within the groups. So we have enough evidence to say that the variation between the groups is higher, which implies that the means between the groups must be different. They are not equal. So we have enough evidence to reject the null hypothesis. We reject the null hypothesis. Not all means are equal. So our intuition was right. We thought that depending on the education level, we're going to work more or less. And this data confirms it. And we are done.